example we have here on site is an example of a temporary structure, but they have various designs when put together in a particular module creates a great living space. But initially we had the same system placed here a few years ago, around 2005 as well, and they since upgraded the system in terms of specifications, energy efficiency, etc. And they erected this particular unit for us over the course of, I think it was about 2 or 3 hours, just recently, replacing the ones that were here. It's an example of a light steel frame structure. This particular one has been used, they use the face brick to do the cladding externally, and internally you've got your dryboard with installation. The nice thing about it is you can actually feel how cool it is on a day like this. It's actually quite obvious in this particular house. So that's an example of a light steel frame.
Just to confirm this is a brick, as you know it, and mortar. So it's not IBT at all. Dr. Mahash spoke of a workshop that we are erecting here at Molobi. So these particular structures are for accreditation in bricklaying training. So we got learners from in and around here to erect these structures. As you can see, they've been trained on building straight walls, corners, there's steps, there's also arches if you go around this structure. There'll be more of them to be built as we go along. But the training center itself currently is accredited to give construction training by CETA.
Welcome to the lab, and what we do, we test ABT samples, traditional building products, aggregates material as well as steel reinforcement. Here we do shrinkage measurements of bricks as well as moisture expansion. However, these are just the conditioning. What we are doing here, we are doing a compressive strength for bent clays. It's a similar test which we would do when we do concrete masonry, and also it will be a similar test what we do when we do concrete cores. Okay, this is the instrument which we've used for his research, and normally we use this in this lab. We normally use this for concrete beams. And like those machines, it will also give us a graph and an indication of the failure load, and then we'll also get an indication of the deflection. But for his case, we were actually doing shear tests, and then this was a suitable machine for his product. And as well, we've done that. We've used that one for compression of his beams, and then we've also used this one for the long beams in bending.
We then took these box beams. The aim is to arrange them into a portal frame. The next 2 pages are the construction method. You can see there, you can see me there with them laid on the floor, and you can see where the different joints are sitting, because remember that I'm taking them as waste materials, therefore they are not continuous, whereas I want to achieve a certain length. Therefore I join them by means of these gang nails. The aim is to arrange them into a frame. If you go 2 pages below, into a frame like that. If you see this beautiful, colorful diagram, you can see that one can arrange them into a portal frame to get the shape of a house. And you can clad these by means of the same material. And on the next page, that is what we want to achieve. You can see on a footprint of an RDP, I'm trying to prove that on a footprint of an RDP house, with sweat equity provided by carpenters, I can actually produce a RDP house at a very minimal cost by using this material that would otherwise have been wasted by throwing them away. It has found various uses as sealing material and other things, but I believe that there is a lot of value in it. Therefore, I'm rearranging it like that. Now I'm testing it here in the lab, because in the life of the building, on the next page, you will see the little building will be subjected to all sorts of loads and wind loads. And we know what happens. It can be blown away or it can fail. And therefore, I've modeled it in the lab here, and I'm testing it like you see to make sure that the strength that I achieve here in the lab is going to withstand the expected loads that I've modeled by means of a computer program. I've looked at it, at all the loads and load combination. What happens if this window is open, the door is closed, or one of the roof sheets is gone? And I've looked at all these load cases at the worst place in South Africa, which is in Beaufort West, where the wind speed is about 30 meters per second.
Everything that comes onto our database, we still need to verify it ourselves and see the performance of that, and we'll be continuously monitoring the performance of those products at the time. The only one condition that we do not have as yet is actually what is called the SANAS accreditation. SANAS, that's your South African National Accreditation System, to accredit this whole laboratory. But in order for them to accredit it, you must have done some work for some years. So they need you to do some work first before they can accredit you. So we are now in the process of doing the accreditation, and we are hoping that beginning of sometime next year, we'll have a full accreditation of this laboratory.